Fuses have been around since the 19th century, and they're still part of the grid. Fuses are designed to blow whenever there's a strong power surge. This stops the flow of electricity and prevents a wiring fire. So by handling power overloads, fuses also take a big load off your mind. Choosing the right fuse depends on your current needs. To make a high-voltage fuse, this machine cuts notches in a long silver strip, which will serve as its element. The notches will help control the way the fuse blows. They melt bits of soft metal onto the strip. The bits will be the points where the fuse blows. They weld one end of the silver element to the top of a ceramic core, and then wind the element around it. This kind of high-voltage fuse will be used in electrical substations. They slide the element core into the fuse casing and bend back metal tabs. Then, using a soldering technique called brazing, they seal everything together. They take a brass washer and wind ignition wire around it. They're assembling the striker pin, the device that indicates a blown fuse and shuts down the power. They press fit the striker pin to the washer and, with the wire protruding, place it in a holding device. They add explosive powder to each striker pin. Then they plug the bottom of the pin with a rubber stopper. Then they press the striker pin into a brass capsule, which will contain the mini explosion that pushes out the pin when the fuse is blown. This test run shows how it all happens. They wrap the pin's ignition wire around an electrical post. They clamp down the pin and position the pendulum that swings to indicate the amount of force with which the pin fires. A jolt of electricity detonates the explosive. This causes the pin to protrude, signifying a blown fuse. Now they slide a metal eyelet onto the striker pin's ignition wire, and then attach a wire coil to it to complete the ignition system for the striker pin. Using a snare, they pull the whole assembly into the fuse. They tie the end of the coil to the fuse's cap, and they press fit an outer cap over the inner one. They fill the fuse with a specific type of sand. It's a filler that absorbs energy from the element when the fuse blows. Automated rods tap the fuses to compact the sand inside. Next, they lubricate an outer cap for the other end of the fuse, and they press it onto the fuse. This machine spins grooves onto the cap, pinching it tightly to the fuse casing. They run a current through each one of these fuses, checking the voltage throughout to confirm that it's in good working order. They pump sealant around the rims of the caps to make them completely airtight. Finally, they affix the safety information. And they also stamp some electrical specifications onto the caps. Now, these fuses are ready to go with the electrical flow, and if there's trouble, they'll blow. It takes a spark to get your motor running. The spark plug was invented in the 19th century to fire the internal combustion engine. There are usually several in an engine, and they fit into the cylinder head. When the plugs are all working, it means your trip will have a good start. The spark plug produces what looks like a mini lightning bolt to ignite the gas that runs your car. To make spark plugs, they blend alumina-ceramic powder and other ingredients with water. After a thorough mixing, the milky-looking brew drains into a big dryer, which converts it back to powder. The powder funnels into a mold. It closes to press the powder into the shape of spark plug insulators, and a binding ingredient in the mix helps them keep their shape. An automated system loads them onto mandrels that spin the ceramic insulators against a grinding wheel. It grinds them into a more graduated shape and does a very precise job. These ceramic shapes are quite fragile, and they'll need to be baked in order to harden. But first, a tester double-checks the measurements with a laser tool. Then they bake in this very hot kiln until they're extremely hard. This takes up to 24 hours. While the insulators are in the kiln, tools ram steel through shaped cavities called dies. They're essentially punching out shells that will be the spark plug casings. Other tools bore into the upper part of the shells to give them a hexagonal profile. This will later enable mechanics to wrench them into a vehicle's engine block. More tooling contours the spark plug shells, and the result is quite a transformation. A conveyor now shuttles the spark plug shells forward as nickel alloy wire unwinds overhead. An automated welder fuses the wire to the shells. This wire will serve as the spark plug's ground electrode, and it will be bent towards a firing electrode later. The space between them will contain the spark. Ridged rollers carve threads in the steel shells so they can be screwed into the engine block. The shell then gets a protective, silvery finish. The ceramic insulators are now out of the kiln, and it's time to roll on the insignia. The insulators then brush by a rubber wheel that coats them with a glaze as a protective finish. They install center electrodes in the insulators, and powder funnels into them to fill the space around the electrodes. The powder is a mix of glass and metal. Automated prongs compress it in the insulators. Grippers then insert the terminal studs into the insulator. The stud will act as the electrical connection to the center electrode. The insulators now go into an oven. The black powder melts around the studs and center electrodes to seal them inside the insulator cavity. Nozzles squirt oil onto the metal shells to lubricate them. The insulators funnel into the grip of robots, which install them into the shells. They slide in easily because of the lubrication job. Tools called shrinking punches apply an electrical current to each shell to fit it tightly to the insulator. A robot positions the assembly right side up with the side electrode protruding, then bends that side electrode towards the center one. The robot then collects the spark plugs and sends them down the line. It's time for an inspection. She looks for imperfections in the glaze, the inscription, and the nickel plating. She measures the space between the two electrodes before sending them over to the packaging department. And now, these spark plugs are ready to keep your engine firing on all cylinders.